So the question of June 2005, question number one. Question number one, and the question reads that Tony Kichumi, a financial analyst at Green City Bus Company Limited, is examining the behavior of the company's monthly transportation costs for budgeting purposes. The transport costs are a sum of two types of costs. We have operating costs, such as fuel and labor, maintenance costs, such as overhaul of engines and spraying. Kichumi collects monthly data on items 1 and 2 above and the distance covered by the buses. Monthly observations for the year ended that 1st of December 2004 were as follows. We have month, operating cost, maintenance cost, and the distance covered. Then Kichumi ran 3 linear regression equations based on the data above and came up with the following results. So we are given that, and we are told to evaluate the linear regression we are told to evaluate the 3 linear regression equations using economic plausibility, goodness of fit, significance of independent variables, specifications of analysis criteria, and we use the 95% confidence level where applicable. Now, we already have covered all those areas. And when the examiner has given you a question like that, you can choose to answer each one independently, or you can combine them. I want us to combine them, and in combining them in a table, we'll have so draw a table like this. So here we will have, remember we are doing reliability tests. The question is about reliability tests. So we will have the details here. And then we have equation 1. We have equation 2. And we have equation 3. And we have equation 3. So when you're given that, that data that way, we are supposed to first of all get the background of the question. You have to get the background of the question or the equations so that you can be able to answer the question well. Now, the first thing is to know the format. Rather, is to know the dependent variable. the dependent variable, the dependent variable. Now in equation 1, the dependent variable is the operating cost. Is the operating cost. Remember that is our y. In equation 2, the dependent variable is maintenance cost. And in equation 3, the dependent variable is total transport costs. Total transport costs. Those things are where illustrated there in the question. Then we have what we call independent variable. Independent variable. Now, independent variable is our x. And according to the equation number 1, you can see it is distance covered in kilometers. So the independent variable is distance. Equation 2, the independent variable is also distance. It's also distance. And equation 3 is also distance. So that is the independent variable. Independent variable. Now that we have that, we can be able to know what format of our equation. What is the format? As we can see, all of them, they have just one independent variable. So this is what we have been calling a simple regression. So this then will be y is equals to a plus bx. This one will also be y is equals to a plus bx. And this one is y is equals to a plus bx. That is the independent variable. Sorry, that is the format of the equation. Then when you have that equation, we have when we have those formats, we can now get the equation, the results, the equation or the parameters. And you remember when we interpreted the table of coefficients, which are the ones that are here, these are the table of coefficients. That is what we did in our last lesson. I told you that now this will be y is equals to, if you look at equation 1, the constant is 309.19 plus the value of the slope, which is 0.054x. 0.054x. Then, and I hope you can see those values. When we go to equation 2, again, you can see the constant. It is 5.55, but the slope which they are calling distance covered is a negative 0.031x. It's a negative that way. And then on this side, we have y is equals to 840.73. 840.73 plus the slope 0.023x. 0.023x. So that is very, very important understanding even before now you can answer the question. So that is what you're supposed to bring as an understanding. So you can draw a line there So that with that now, we can be able to answer our question. So the first requirement is economic plausibility. Economic plausibility. Economic plausibility. That's the first thing we are told to test in that question. Now, I told you economic plausibility is about judging whether the observed relationship is logically defensible and whether it is making economic sense. Now, for us to judge that, we need to know what is the expected relationship and what is the observed. And you know, in our notes, we said we have three types of relationships. We have a direct relationship. This is where they change towards the same direction. We have inverse relationship. This is where they change towards opposite directions. And we have what we call the null. That's where they don't affect each other. Now, in judging economic plausibility, you have to come first of all here and tell us what is the expected relationship. What is the expected relationship? I want you people to tell me, what kind of a relationship would you expect to see between operating cost and distance? Is it direct or inverse or null? Someone to respond. What would you expect in general? Yeah, good. I can see direct relationship. Thank you. Thank you for those responses. So we expect direct. Tell me, what do you expect between distance and maintenance cost? Is it direct, inverse, or null? What do you expect? Yeah, I can see it's also direct. We expect a direct relationship. And the same case will happen with the transport and distance. We also expect a direct. As in, when one is going up, the other one is also going up. As you do more distance in kilometers, then you're also having more costs. Then from there, you bring what we call observed relationship. Observed relationship. Now, observed relationship, it is what you can see here, according to this sign. So you remember this one we said is direct. So we have observed a direct relationship. And if you want to provide evidence, you can still quote this one in brackets. That's why we are saying what we have observed is inverse. Sorry, it's direct. Then here we have inverse. And we are saying so because of this. And then here, this is direct. And we are saying so because of 0.023. Yeah, it's direct that way. Direct that way. So, the conclusion, when you compare these two, you make the conclusion. Make the conclusion. So the conclusion that we are going to make is now that these two agree, it is plausible. It is plausible. That relationship is economically plausible. That is what we said. But here, now that they are not the same, this is direct and this is inverse. Now that one we call it spurious. That one we call it spurious. Then these ones, they agree, so it's called plausible. It's called plausible. called plausible. So sasa draw a line ndio ufunge hiyo. So after you have drawn the line, mine I will have to rub so that I get enough space to continue with the same. So tunaendelea tu na hii table. So the next thing we are taught to do is to test the goodness of faith. So goodness of faith. Goodness of faith tests. Goodness of faith tests. Now, when you see goodness of faith, you are supposed to go back to your notes or to your file and recall that we have 6 goodness of faith tests. We have what we call R square. We have what we call SE. We have what we call F. We have what we call R. We have what we call SP, and we have what we call T. So those are the 6 goodness of faith tests. So when you have all of them that way, you now check which ones have appeared in your question, in your report. Those are the ones you comment about. So when I look at my report, I can see R square, it's there. But I cannot see the standard error of estimate, it's not there. I also cannot see F. I also cannot see R. But I can see the standard error of the slope, if you remember what we said about the interpretation of the table of coefficients. And I can also see T. So those are the 3 ones that we shall comment about. They are the ones that are present. They are the ones that are present. So let's start with the R square, coefficient of determination. You can either write in full, or it is preferred you write in full in the exam. But now I will write the initial R square. But in the exam, ukiandika initials, no harm. Those are the standard letters that are used. So R square, we need first of all to know the value, what it is, or the size. Now you can see in equation 1, R square is 61% or 0.61. You can either write it as a decimal or you can write it as a percent. In equation 2, it is 0.68 or 68%. Equation 3, it is 29% or 0.29. Then after you have known that, what next? Tulisema that the higher the value is, the better the equation. So the comment that we can make is depending on how high it is. Tukasema a relationship with the R square at least 80, 0.8, that one you can accept. And if it's below 60, you can reject. Now, between 60 and 80, there you accept at your own risk. We are not very sure. You can accept. So we are going to make the comment that here we can accept, was it 61? Here we can accept, it's also more than 60. But this one we should reject. We should reject. It is below 60, so it is very weak. That one should be rejected. We should reject. The next item that we need to comment about is SB. Again, we need to get the value, the size of it. So for SB, the standard error for the slope in equation 1, you go to where there is distance, you can see we have 0.014. Then in equation 2, we have 0.007. And equation 3, we have 0.011. 0.011. So we need to make a comment, and the comment will be guided by what we said. We say that the smaller the value, the better the equation. So simply compare here the highest, the lowest, and the average or the medium. So as you can see, this is the highest. So if it's the highest, we may need to avoid. This is the lowest. But remember, in as much as this one is appearing as the lowest, we shall kata when we say it is spurious. And this one we can say it is medium, or it is average, or katikati. It's medium. Is medium. From there now, from there we go to who? To T. Now we talked of T na tukasema there are two values that you need to compute. You need to get the calculated, which we say T calculated should be given as B, you divide by SB. It should be B, you divide by SB. So in equation 1, the slope is 0.054. You divide by the standard error of the slope, 0.014. Give me the answer to that. Give me the answer for that. I'm waiting for the answer. 3.36, good. 3.36. So if it is 3.36. Yeah, 3.86, good, 3.86. And this 3.86, you can see the examiner has already computed for you, it is there. But I just wanted you to confirm the formula that I gave you, because not everywhere the examiner will have computed for you. So that is how you get it. You can also confirm even for the second one, that if you got negative 0.031, It divided it by 0.007, you would end up with negative 4.43. And the same case here, 0.023, when it's divided by 0.011, the answer realized should be 2.09. The answer realized should be 2.09. So now from there, we have to get what we call plus or minus T critical. And this one, we are getting it at 95% at 1 minus 0.05 out of 2, 95%. And the degrees of freedom will be n minus 1. So that's how unahesabu how many values are these. And you can see clearly they are 12. They are 12 months. So it's going to be 12 minus 1. 12 minus 1. So with that, we go to our student T tables that we have been using, this one. And when we are there, we look at two-tail confidence. Two-tail, then you move backwards to where there is 95%. And then you go downwards to where there is 11. And then you tell me what is the value there. Write for me the value that you can see. I'm waiting for the value. Yeah, 2.201. So nasema plus or minus 2.201. The same case here, plus or minus 2.201. Plus or minus 2.201. So if you remember what we said about this test, these tests, we had something like this. You look at the t-test, the rule, hapa ndio tulikuwa na negative, so like now here it will be negative 2.201, na hapa tukakuwa na positive 2.201. Positive 2.201. Then from there, we have, tukasema, if it is inside here, you accept. In other words, it is insignificant. And if it is on the lower side here, it is to reject. It is significant. And on the upper side, you reject because it is significant. That is what we wrote in our notes. So that being the case, you now come and check. This 3.86, when you check with this one, is it in the region of significant, insignificant, or significant? Where do you find this one? This 3.6 This is 0.86 when you compare with this. Where is it? Yeah, it is significant. So that means now we come here and make the conclusion. The conclusion, this one is significant. Significant. This one, you can see it is on the negative side. Iko na huku chini, so it is also significant. Significant. And this one, it is also, no, it is within this 2.09. It is within this plus minus 2.2. So it is insignificant. Insignificant. So that is how you go about the goodness of faith texts. Are we okay with that? Okay. So let us now go to the next one. The last requirement was saying we get specifications analysis criteria. The specifications analysis criteria. Specifications analysis criteria. Now, in our note, we never talked about this, or we never mentioned about specifications analysis criteria. But as I always tell you is that we do not teach you everything. We teach you some things that you should use to do other things. I taught you 3 things: the economic plausibility, goodness of faith, and assumptions. So we already have discussed the first 2. So when the examiner is using a name that your teacher did not tell you, you should know it is the other one that we called the assumptions. And in grammar, an assumption is a condition. A condition is a specification. So when they talk of specifications analysis criteria, they are simply telling us about the assumptions. Now, I gave you 6 assumptions. I gave you 6 assumptions. Now, the first assumption, we called it linearity. We called it linearity. And that one will apply here. Linearity. It will apply here because we said you either test it using the graph or using the equation. And in our question here, you cannot see a graph, but we can see the equations. So we are going to say this one is linear since the equation obtained, y is equals to, you write the equation, y is equals to 309.19 plus 0.054x is of the form y is equals to a plus bx. Yeah. So that is the comment that we will make. It is linear. And the same thing now, you will copy for the others. They are also linear. And copy their equations. And copy their equations. The equations tulikuwa nazo hapo juu. So make the same comment. Tuseme linear since the equation obtained. Sasa unaandika hiyo equation yake is of the form. This one remains. Even where we have negative, weke tu ikiwa positive hapa in the form. But hapa uandike ile equation tulikuwa nayo. Na hapa the equation tulikuwa nayo. Do that. We go to the next. Okay, so I believe we are through with that. We are through with that. Let's go to the next assumption. The next assumption is the zero mean for the error terms. Ikifuatwa na the constant variance for the error terms. Ikifuatwa na normality for the error terms. Now, in our question here, we have not been given those values of the errors. If you look at the question we used for illustration in our notes, you'll be able to find the column of the errors. Now, your column of the errors is not given here. So those three assumptions cannot be tested. So we got to the fourth assumption, actually the fifth assumption now. The third assumption is what we call the autocorrelation, the independence of the dependent variable. So let's just call it autocorrelation. Autocorrelation. And autocorrelation, we say it is tested using Durbin-Watson statistic. So you will come here and give us DWS calculated, the Durbin-Watson statistic. So in our report, Durbin-Watson statistic is given as 1.61. Huyu mwingine ni 1.72. Na huyu mwingine ni 2.34. 2.34. Those are the Durbin-Watson statistics. Then conclusion or the comment. Tulisema if Durbin-Watson statistic is between 0 and 4, there is no autocorrelation. So you can see all of them, they are within that. So you just say no autocorrelation. No autocorrelation. Even here, no autocorrelation. And even here, no autocorrelation. Yeah, they are all within the range. So there is no autocorrelation. And the last assumption is called what? Is called collinearity or multicollinearity, the independence of the independent variables. And if you check our notes, we said it is used where we have more than one independent variables. But if you look at where we began, where we wrote about the independent variable, each of these has just one independent variable. So we cannot test that assumption in this question. So that is all that you were supposed to do in that kind of scenario. That kind of scenario. So if that is true, then that is true. What else do we say? Is that we have finished that question. And I think I need to give you an assignment. Question. Remember to do these assignments. They are very, very important. They are not compulsory, but they are very necessary. You can try this one of May 2018. May 2018, question 2B. May 2018, question 2B. So when I give you these assignments, you should be doing them and you submit for marking. You scan, because you're far away, you scan, then you send to me via email or WhatsApp. I will mark, then I will get back to you. If you are not able to do that and you still need to see the solutions, then you can buy my revision kit. The revision kit will cost you 1,500. That is also the other way. If you are still not able to buy the kit and you're not able to scan, then just do and keep them, but ensure that you do. ensure that you do. Ensure that you do. Either you buy the revision kit or you submit, but ensure that the minimum is that you do the assignments. Very, very important. So let us proceed now. Or maybe I need to ask whether we are okay. Nyabuti, are you okay up to that point? Okay. Wesley? Enul? Yeah, so we are okay. And if we are okay, let's proceed on to you're still looking at the forecasting methods. We had listed 10 methods, but we said we'd only do 7. So let's now look at the 7th one, which is called running curve method. Running curve method. Right, that a running curve is a function used to describe how the average completion time per unit, describe how the average completion time per unit declines systematically as more and more units are made. As more and more units are made. Full stop. Running occurs as a result of the worker becoming familiar with the task. As a result of the worker becoming familiar with the task and acquiring more skills. Becoming more familiar with the task and acquiring more skills. Full stop. Learning is short-term. Learning is short-term and is usually forgotten. When there is a break. It's usually forgotten when there is a break. When there is a break. Full stop. If the exposure is prolonged, for a long period of time, if the exposure is prolonged for a long period of time, learning becomes experience. Learning becomes experience. Learning becomes experience. Full stop. As a result, experience is difficult to forget even after the break. As a result, experience is difficult to forget even after the break. Even after the break. Full stop. It is more beneficial for companies. It is more beneficial for companies to have experienced workers. It's more beneficial for companies to have experienced workers than learned workers. Than learned workers. Than learned workers. But the following factors make it almost impossible. But the following factors make it almost impossible to have experienced workers. Make it almost impossible to have experienced workers. Number one, short-term planning period. Short-term planning period, which is not more than 1 year. Short-term planning period, which is not more than 1 year. Number two, high mobility of workers, especially when young. High mobility of workers, especially when young. High mobility of workers, especially when young. Number three, presence of numerous inevitable demotivators. Presence of numerous inevitable demotivators. Numerous inevitable demotivators. Then down there we write that a learning curve is an exponential function. Learning curve is an exponential. A learning curve is an exponential function of the form, exponential function of the form y bar is equals to ax raised power b. And this one we call it average. Or y without a bar, ax b plus 1. And this one we call it total. Where y bar we are saying is the average time. The average time, maybe I can add this one, although it's not necessary. When you see average, you should know it's for 1 unit, but let me add. the average time per unit. When you see Y is total time for all the units made, A is time taken to make the first unit, time taken to make the first unit. X is total units made, or the cumulative units. B, we normally call it running index. And this running index is given as a logarithm of R, which is divided by logarithm of 2, logarithm of R divided by logarithm of 2. And this R is the running curve rate. It's the running curve rate. The running curve rate. It's the running curve rate. Okay, then down there you write that the decline in time is only noted at double points. It's only noted at double points as shown below. That is x-axis. So we have something like this. This space here is called K. And we have another one here like this. And we have another one here like this. So this is x1, and this is x2, and this is 2x1. It is 2x1. That's what you're calling double points. Then this one, it is y bar t. Y bar t. Or y bar 1. Let me use 1. And then here we have y bar 2, and this is given as r, y bar 1. That point, this is 0 here. So here I have y-axis. Now this one is the average, and average is y bar, which you're saying is given as ax raised power b. Then total inachomoka hapo hivyo. Total. So total is y is equals to a x b plus 1. Now on this side, this is time. Remember, this is 0, and these are units. So what we are saying up to that point is, as the worker does more units, the average time continues to reduce. You can see it is like it's headed to 0. It's like it's headed to 0. It's headed to 0. And then it stabilizes at K. But the total time is increasing. Now, when we see that the time is reducing, we say that the worker is running. Anasoma, anapata ujuzi. And we are also saying that running is short term. So when you take a break, it is usually forgotten. It's like what in academics we call the cramming. Now, if you do something for wrong, you simply become experienced, and experience is never forgotten. We are also noting that a company would wish to work with people who are experienced. Even you as an individual, anytime you require a service, like the one that you require from us or being taught, you should go for the experts, people who have been experienced. They are able to deliver quality, they are able to deliver within no time, or within some good time, some reasonable time. But for various reasons, we don't have people who are very experienced in many areas. One, most of the things we do for a short period, then we go to something else. Mapanga kitu mnafanya several months, then you go to something else. So you cannot master. The other thing is the workers keep on moving, especially when people are young. Leo uko kwa hii kampuni, tena umehama, umetafuta ingine, those kind of things means you cannot settle down and learn. And then the other issue, which is common to all of us, we have what we are calling numerous demotivators, mashida mingi. Hata nikiwa hapa class, kuna mashida iko kwa kichwa yangu nafikiria. Hata wewe ukiwa kwa hii class, kuna mashida mengine kwa kichwa yako yanakusumbua. So hata nikiongea mambo ya learning curves, na hiyo mambo iko kwa kichwa yako, to balance them, it becomes difficult. Yeah. And that is the reality of life. As the reality of life, we are dealing with very many sources of stressors. That's why you need the counseling. Okay, good. In my other life, I do counseling psychology. So that is also my field. I practice counseling psychology, where I target individuals. I also target corporates. So in case one of these fine days you get someone who requires counseling, you can refer them to me. I'm a certified counseling psychologist. And I also do that even with corporates. So where you work, in case you require workplace or what we call the employee assistance program, those trainings, we do them. Thank you. So that was by the way. I was doing that as I was giving you time to complete this. I hope everyone has drawn that. Now, if you have drawn, down there you write that K represents the minimum time. Represents the minimum time that is taken. That is taken to complete a unit. Complete a unit at the highest level of learning. At the highest level of learning. At the highest level of learning, full stop. When K is observed, the process is said to have reached a steady. The process is said to have reached a steady or equilibrium point, equilibrium point, since there is no further decline in time taken. Since there is no further decline in time taken per unit. There's no further decline in time taken per unit. So we are saying that when you observe K, it means that we have reached the equilibrium point. We have reached the equilibrium point, and beyond that, time does not increase. That's what unaona hapa ni kama ina stabilize. Yeah, inasimama. Even as you do more and more, you cannot reduce the time. Na ukicheza, what happens is sasa ukianza kuchoka inaanza kupanda tu. You start now taking more time. Good. Let's now look at assumptions used in learning curve method, or the assumptions. Here's assumptions. Assumptions. Number one, the worker is highly motivated. The worker is highly motivated. Number two, there are no breaks. There are no breaks. Number three, sufficient data has been gathered. Sufficient data has been gathered to establish the running rates. Sufficient data has been gathered to establish the running rates. Number four, the job is predominantly manual. The job is predominantly manual. Number five is that the job is directly related with time. The job is directly related with time. That is direct labor. That is direct labor. So what we are saying at that point is that the worker is highly motivated. They are happy with what is happening. When you are happy with what is happening, you are able to learn. You are able to get to understand it better. The other thing is there are no breaks. We don't keep on taking breaks. We are consistent in what we are doing. Then we have sufficient data. We have sufficient data that we can be able to gather and compute the running rates. Then the job is predominantly manual. What we are doing is manual. It's not more of mental. Although even in mental, we also run. The other thing is the job is directly related with time. Remember here, we are talking of time here and the units. So we should be able to see a very clear relationship. As we change the number of units, we are changing also the time. Or as time changes, the units are also changing. Good. From there, let us now look at stoppage of learning. What can make someone to stop to learn? Stoppage of learning. Stoppage of learning. So I'll give you a few factors. Number one is fatigue. fatigue. Number 2 is demotivation. Demotivation. Number 3 is presence of breaks. Presence of breaks. And number 4 is change in technology. Change in technology. Change in technology. So when we have those things coming into play, you find that you're not able to learn what you should have learned. That becomes a challenge. Okay, let's finally look at applications of learning curves. Applications of learning curves. Applications of learning curves. Applications of learning curves. Number 1 is forecasting of costs. Forecasting of costs. Number 2 is setting of selling prices. Setting of selling prices. Number 3 is setting of labor standards. Setting of labor standards. Number 4 is designing of remuneration policies. Designing of remuneration policies. Another one is performance measurement. Performance measurement. Number 6 is competitive bidding. Competitive bidding. Competitive bidding. Number 7 is standard costing. Standard costing. And number 8 is project appraisal. 8 is project appraisal. Yeah, so we will call it a lesson at that point because I can see we have like 11 minutes. I cannot be able to start a question and finish within that time. So let's meet in our next lesson. That should be on Saturday, God willing. Thank you and have a good day.